Good morning, students. So in the last video lecture, we were discussing about the Fourier series of sine and cosine series, and also we discussed about the odd and even function of Fourier series. And we are going to continue the same thing. We are going to discuss some problems on Fourier series, and at the end we are going to discuss about half-range Fourier series. So I will continue. Summary of even and odd function. So this is the continuation of the last video lecture. Summary of even and odd function. So case 1, when f of x is even, for example, when you take f of x equal to, this becomes cos nx is an even function, and f of x equal to sin x is an odd function. So even function is f of x, you will have to substitute minus x. So f of minus x becomes f of x itself. Suppose if it is minus sign, this becomes odd function. F of minus x equal to minus f of x is an odd function. F of minus x equal to plus f of x is nothing but even function. Okay. So for the even function, we have two terms. The coefficient, Fourier coefficient Bn becomes 0. So we have three coefficients. One is a0, another one is an, then another one is bn. For the even function, bn becomes 0. So there exists only two terms, two coefficients, Fourier coefficients. One is a0 is given by 2 divided by pi, 0 to pi, f of x dx. Then another one is an, which is equal to 2 divided by pi, 0 to pi, f of x cos nx dx. And for the second case, if the function is odd function, so f of minus x equal to minus f of x. If function is odd function, then for example, for odd function, the famous example will be sin nx. Sin of minus theta equal to minus sin theta, whereas cos of minus theta equal to plus cos theta. So in this case, the Fourier series and the coefficients a0 is 0, an equal to 0, bn alone exists. And this is for the odd function and this is for the even function. Bn alone exists. Bn equal to 2 divided by pi, 0 to pi, f of x sin nx dx. So let us solve some problems on Fourier series and find the Fourier constant a0. The limits are given as like. So f of x equal to minus x, x lies between minus pi and 0, and x lies between 0 and pi. What is asked? Find the Fourier constant a0 is asked. Okay. This goes from minus pi to plus pi, correct? The limit goes from minus pi to plus pi, the total limit. Look at the limits, minus pi to plus pi. First limit is x lies between minus pi and 0. Second limit is x lies between 0 and pi. Corresponding f of x becomes minus x and x. Okay. Now, we will have to find out whether it is even function or odd function. We will check. So before calculating the Fourier coefficient, we will check whether this function is even function or odd function. For the even function, you will have to double the limits. For example, minus pi to plus pi, the limit goes like this. You can write 2 times 0 to pi. Is it okay? For the even function, not for the odd function. For the even function, if the limit is minus pi to plus pi, you can change the limit as 2 times 0 to pi for the even function alone. That is easier for getting the results. So first we'll check whether it is even function or not. Okay, whether it is even function or not. For the even function, you have to substitute instead of x, you have to substitute minus x. For the even function, you have to substitute. For the odd function too, doesn't matter. You just substitute instead of x, you have to substitute minus x. So instead of x, you have to substitute minus x. Limit also, look at the limit. Here also you have to substitute instead of x, you have to substitute minus x. So I have substituted instead of x minus x. Here also I have substituted minus x. Okay, instead of x, I have to substitute minus x. Now look at the terms here, minus minus plus, it becomes plus, so plus x. And you have minus x, this is your minus x. Now I can change the limit with taking the negative sign. See here, you have minus pi. I am going to remove this minus pi. Instead of writing less than, I am going to write greater than. We can do it. Is it okay? So I am going to remove this minus pi, say plus pi. But when I am going to remove minus sign, so immediately I will have to change the sign, greater sign, so greater. So now x lies between pi and 0. Is it okay, everybody? And here too. So here minus x, you are going to change it into plus x. So you have to change the greater sign. So x lies between 0 and minus pi. Is it okay? So the moment when you are going to change the sign, this becomes minus. So minus pi. So that's why it's minus pi. Look at the limits. I have changed the limits here. Okay, replacing less sign into greater sign. Okay, now I have written the same thing here. Same thing here. This can be written exactly like this. See here, x lies between 0 and pi. So I can write x lies between 0 and pi. Both are the same. Both are the same. And here too I can write, instead of x lies between 0 and minus pi, I can write x lies between minus pi and 0. See, both are the same. Now you compare this one and this one. This is the original problem. We have obtained the result. You compare this one and this one. Both are the same. See, f of x equal to minus x. See, f of x equal to minus x. Look at the limits. Minus pi. See, x lies between minus pi and 0. Okay. Similarly, x. What about x? X is here. And here it is f of x. Here it is f of minus x. I told you just now f of minus x equal to f of x for the even function. If f of x equal to, you are going to replace with the minus sign, that f of minus is equal to minus f of x will become odd function. Okay, so now f of x equal to f of minus x. So this is an even function. Okay, so for the even function we can change the limit as I said earlier 2 times. Okay, we will do on both sides. We will do. So what is asked? A0 is asked. A0, the Fourier coefficient A0 is asked. Constant term, DC term. So A0 equal to 2 divided by pi, 0 to pi. See, for the even function, 0 to pi f of x dx. Okay, so A0 equal to 2 divided by pi, 0 to pi x dx. 2 by pi, integrating x, that will give you x squared by 2. Applying the limits, that will give you 2 pi squared by 2 pi. 2 to get cancelled, this pi will get cancelled, you have pi. So A0 equal to pi. Okay, is it okay? It's very simple one. 0 to pi. Look at the limits, minus pi to plus pi. Okay, minus pi to plus pi. I will change the limit 0 to pi 2 times. Your original A0 will be A0 equal to 1 by pi. Now you have changed into 2 divided by pi. Is it okay? 2 by pi. But I will change the limit 0 to pi. So this is one method. We can calculate it. We will have to convert this one into even function, and we can calculate the Fourier coefficient like this. This is one idea. Other idea is take as it is. Take as it is. Okay, take as it is in the sense A0 equal to 1 divided by pi. See, minus pi to plus pi. I have not changed it to odd function or even function. Earlier I know that this is even function. So I have converted into even function and I have calculated A0 equal to pi. Whereas in this case now we are going to do as it is. So A0 equal to 1 by pi minus pi to plus pi f of x dx, which is equal to 1 by pi. I can convert this one minus pi to 0, 0 to pi. I can separate the limits according to the problem. This problem is given as 0 to pi minus pi to 0. So minus pi to 0, 0 to pi. What is f of x in this limit minus pi to, this is minus x. So I have written minus x here. What is f of x in this limit 0 to pi, 0 to pi? So this is x. F of x equal to x. So instead of f of x, you will have to substitute minus x. Instead of f of x in this limit, you will have to substitute x. That's all. So now easy to integrate. So minus x squared by 2, you are going to integrate this one. So this becomes minus x squared by 2. This becomes x squared by 2. Substitute the upper limit. That will give you minus sign is here. Minus pi whole squared divided by 2. Substitute in the lower limit, that will give you 0. And substitute in the upper limit, it will give you pi squared by 2 minus 0. See, I have written here minus sign is there. So removing the minus sign, I can change the limits. So I am going to remove this minus sign, change the limits. So this becomes plus x squared by 2, 0 to minus pi. So 0 to minus pi. So 0 minus of minus pi whole square divided by 2. Okay, is it okay? So now this is minus pi whole square, this becomes plus pi. So minus plus, so this is plus. Pi squared by 2 and this is pi squared by 2. Pi squared by 2 pi squared by 2, 2 to get cancelled. Pi will get cancelled, you have A0 equal to pi. So in this case also we are able to get the same answer. See here, the last case we have converted into even function and we obtained A0 equal to pi. In the next case, we have not converted to even function or odd function, and just we have done a naught equal to pi. Is it okay? So whichever the method that is here, you just follow. But as far as I am concerned, you should know what is even function and odd function. Okay, it's very important. Now let us go for the next problem. Find the series of sines and cosines of multiples of x which represent f of x in the interval x lies between minus pi and plus pi. Okay, so in this interval, so f of x is given as 0 in this interval, whereas f of x equal to pi x by 4 in this interval. So we are going to find out the series of sine and cosine. So we have to find out sine series and cosine series, and we are going to add. So we know about Fourier series very well. Okay, this is where Fourier series. We are not going to find out a0, an, bn. We are going to find out and substitute and find f of x. So that's the idea. What is asked? Find the series of sine and cosine. So this is series of sine and cosine. F of x is asked for sine and cosine. So you have to find out a0, an, bn. So we know the formula for a0. a0 equal to 1 divided by 2 pi minus pi to plus pi f of x dx. Okay, and an is given by this formula and bn is given by this formula. We know about this. Okay, this is cos series and this is sine series. Okay, we know all. And in the problem it is given as f of x is given as this. So first we will find out now a0. a0 equals 1 divided by 2 pi minus pi to plus pi f of x dx. Okay, f of 3. We will substitute. So it's given here. Okay, so 1 divided by 2 pi minus pi to 0, and this is 0. So this is 0. And next limit will be 0 to pi. See, 0 to pi. In this limit, f of x equal to pi x by 4. So instead of f of x, you will have to write 0 here for this limit. And instead of f of x, you will have to substitute pi x by 4. See, pi x by 4. So this becomes 0. You pull pi by 4 out and integrate. So that will give you x squared by 2. So this becomes pi squared by 2. Correct? Pi squared. This pi and this pi will get cancelled. 2 4s are 8, 8 2s are 16, so 16. And this pi squared, so pi squared by 16. Very simple one. We have calculated now the coefficient a0, dc term. Okay. Now we'll go for an. Next one is an. An is given by the formula 1 divided by pi minus pi to plus pi f of x cos nx dx. Okay. As usual, just to separate the limits, minus pi to 0, f of x cos nx, where f of x becomes 0 here as it is given the problem. So this becomes 0, and this f of x instead of f of x you have to substitute pi x by 4. So 0 plus pi x by 4 cos nx dx. Okay, you pull pi by 4 out, and this pi will get cancelled. You have 1 by 4. So x cos nx dx. Any doubt? So we are going to calculate, we are going to integrate x cos nx by using Bernoulli's formula, which we learnt in the last video lecture. Bernoulli's formula, it goes like this. Integration of u v dx equal to u v1 minus u dash v2 plus u double dash v3 goes on. So here u equal to x and v equal to cos nx. And here you have to differentiate, here you have to integrate. Bernoulli's theorem. Here you have to differentiate, here you have to integrate. So ux, integrating, that will give you u dash equal to 1. What about u double dash? What is the answer? 0. Very good. So u double dash equal to 0. You can't do it later. So only two terms alone exist. Only x and u and u dash, u prime alone exists. And what about v equal to cos nx? So just v1 equal to integration of v dx, that will give you cos nx dx equal to sin nx by n. v2, so you have to integrate this. Okay, this is the formula. v dx is the formula, v2. So here v1, this becomes v1. So you have sin nx by n. I have pulled 1 by n out. So this becomes 1 by n. Integration of sin x will give me minus cos nx by n. Okay. So sin nx will give you minus cos nx divided by n. Is it okay? So I can pull n out. So that becomes n squared cos nx. So there exists only two terms. Now substitute in this formula. So we have now this integration of x cos nx dx becomes, you have 1 by 4, correct? 1 by 4, 1 by 4 u v1. What is u? U is here, v1 is here. So u v1 minus u prime v2 this here. Limit goes from 0 to pi. Okay. Now we will substitute first upper limit for the first term. Okay. Sin pi is sin pi is 0. So substituting the upper limit, this term will become 0. Just substitute the lower limit here. Sin 0, 0. So instead of substituting sin nx x for x, you have to substitute 0. That also becomes 0. So this term will go off. Simple one. For the upper limit and lower limit, this term will become 0. And for second term, minus plus. Okay. First substitute the upper limit. Okay. So this becomes 1 by 4 cos nx by n square 0 to pi. First we will substitute the upper limit. So substituting the upper limit, cos pi. Okay. Cos 0 is 1. Cos pi is minus 1. But here it is n pi is given. N pi. So n pi. So cos n pi minus 1. Cos 0 is 1. Substituting the lower limit, that will give you 1. Instead of x, you have to substitute 0. So cos 0 is 1. Is it okay? So you have now 1 by 4 n squared. See, I have pulled n squared out. So you have 1 by 4 n squared. This becomes cos n pi minus 1. We already studied cos n pi equals minus 1 to the power n in the earlier classes. Of course, you can also do it. So this becomes cos n pi becomes minus 1 to the power n. So this becomes minus 1 to the power n minus 1 divided by 4 n squared. Now we will go for the bn calculation. So we have found out now an equal to this term. An equal to this term. Now what about bn? Bn equal to 1 divided by pi minus pi to plus pi f of x sin nx dx. So this is your assignment. You will get the answer exactly like this, but already we have done in the video lecture earlier. So the same term. Okay. So this becomes minus 1 to the power n pi divided by 4n, and that is the value for your bn. Okay, bn. So we have found out now a0, an, bn. Substituting the Fourier series. So your f of x equal to, this is your a0, this is your an, and this is your bn. Bn, look at the same one, minus is here. Okay, minus, and I have written minus I. Now I have written the same term here, except plus and minus, that is replaced with the minus I. Okay, plus into minus, that will give you minus I. Otherwise I have written the same thing. So this is a required representation of Fourier series of f of x. Okay, this is a required series. Come on, see here, what is asked? Find the Fourier series of sine and cosine terms. So we will have to find out a0, an, bn, substitute here. We have substituted and we have obtained the Fourier series. Is it okay? So f of x equal to a0 term, this is an term, this is bn term. So this is a required representation of Fourier series of f of x. Okay. Now we will go for the next title, half range of Fourier series. Half range of Fourier series. Half range Fourier series. So earlier minus pi to plus pi. So this time we are going to have 0 to pi. Half range. Either you can see 0 to pi. The limit goes between 0 and pi. Sometimes 0 to L. Okay. In this case, the function is defined in the interval 0 to pi. It is immaterial whatever is the value of the function outside the interval. So we don't bother about outside the value. 0 to pi, that is the required one. Outside 0 to pi, we don't bother. So it is immaterial. The Fourier series in this case will contain only, this also will contain sine and cosine term. So depending on the nature in the sense, either it is odd or even function. Okay. Half range Fourier sine series. So there are two cases, half range Fourier sine series, half range Fourier cos series. So there are two types. So we have already defined, this one. I have written the same thing here. The half range Fourier sine series given by this formula. Okay, your f of x is given by this, and your bn the Fourier coefficient Bn is given by this formula. Similarly, half range Fourier cos series, cosine series is given by this formula, and your An is given by this expression. And what about A0? A0 equal to 1 by L, as I said earlier, either it can go from 0 to L or 0 to pi. Can you remember? Just now I said. So 1 by L, 0 to L, f of x dx. So this is your A0 and this is your An. Okay. So now let us look at some examples. Find the half range sine series of the function. So function is given by this. Here f of x equal to 4, 0, 4. So x lies between 0 and pi by 2. Okay, 0, x lies between minus pi by 2 plus pi. See here, look at the limit 0 to pi. It is not minus pi to plus pi. Okay, as I said earlier, the limit goes from 0 to pi. 0 to pi. So what is asked? Sine series. Sine series only f of x equal to bn sin nx. Okay, sine series. Correct? Your bn equal to 2 divided by pi. See, sine series, already we know sine series, the sine series. This is your sine series. So 2 by pi, 0 to pi, 0 to pi, f of x sin nx dx. F of x, what is f of x? F of x, there are two values, f of x equal to 4 and f of x equal to 0, depending on the limits. So 2 divided by pi, 0 to pi by 2. First we will go for f of x. F of x equal to, this is your f of x, 0 to pi by 2. So 0 to pi by 2. In this limit, f of x equal to 4. So instead of f of x, I am going to substitute 4. So 4 sin nx dx plus f of x equal to 0 here in this limit, minus pi by 2, no, plus pi by 2 pi. So you have 2 divided by pi by 2 plus pi, f of x sin nx. In this limit, f of x equal to 0. So the second term will go off. So you have only first term alone. So we have 2 divided by pi. Instead of f of x, you have to substitute 4. 4 2s are 8. So 4 2s are 8. 8 divided by pi, 0 to pi by 2 sin nx dx. So integrating sin nx dx, that will give you minus cos nx by n, 0 to pi by 2. Okay. So I am going to remove this minus sign. I am going to change the limits now as usual. Okay. I have written exactly like this. Now cos 0 is, substitute the upper limit. Cos 0 is 1. So cos 0 is 1. So okay. I have pulled n out. So 8 divided by n pi. And cos 0 is 1. What is the lower limit? Minus cos n pi by 2. Correct. I am going to substitute, instead of x, you have to substitute pi by 2. So this becomes cos n pi by 2. Now look at this series. N equal to 1, see n equal to 1, 2, 3, 4. For all those, this will become 0. So you have f of x equal to 8 divided by n pi. Okay. See, look at the term now 1. You substitute n equal to 1. Cos pi by 2. Cos pi by 2 is 0. Okay. Look at now 2. 2 will get cancelled. Cos pi equals minus 1. Correct. So this becomes 1 plus 2. So this may be wrong. You write as it is like this. You don't write this. So I have written for n equal to 1 alone, I have written. For n equal to 2, 3, 3, this will become wrong. Okay. So you write this alone. F of x is given by this. Okay. Now find the half range cosine series. Earlier we calculated sine series, half range sine series. Now f of x equal to 4 in this limit, the same limit. X lies between 0 and pi by 2, and 0, x lies between minus pi by 2 and plus pi. So what is asked? Cosine series asked. So f of x equal to, you have to find out both a0 as well an. So a0 plus sigma over n equals 1 to infinity an cos nx. You have to find out a0, you have to find out an. a0 is given by this expression and an is given by this expression. So your a0 is given by this, your f of x is given by this this expression. So instead of f of x, you have to substitute 4 here. Instead of f of x, you have to substitute 0 here, separating the limit 0 to pi into 0 to pi by 2 to pi by 2 0. You have to separate the limits. 0 to pi, I am going to separate because this half range. So 0 to pi by 2 to pi by 2 pi. Okay. Now, so we'll simplify this. So this becomes 0. Second term becomes 0. The first term is 4 dx. Okay. I can pull 4 out. 4 out. So that will give me 8 divided by pi. And here cos nx. And here it is cos nx. And of course, so we have simplified as cos nx dx. 0 to pi by 2. Cos nx dx. Integrating, that will give you sin nx by n. 0 to pi by 2. Sin 0 is 0. Of course, the lower limit becomes 0. You have to substitute the upper limit, that will give you sin n pi by 2. That's all. So your an is given by 8 divided by n pi sin n pi by 2. Okay. So that's all. So we have found out now a naught. We have found out now an. Okay.